views. Right? What's exploded? It's when you take a three-dimensional object and you blow out all of its component parts. Okay, that's basically what it is. So here, this would be an example of a three-dimensional object that's been exploded. It's got 6 faces, okay? And we can see, you know, this is a side, this is a side, this is the top, this is the bottom, this is the front, because it's in front of this, which is the back, okay? So what we're going to look at is how do we take an exploded view object and make it into 3D? And how do we make take a 3D object and draw an exploded view? The one thing you do have to remember is the scales have to stay the same. And we'll talk about that. Like, yes, I'm sure all of you could draw this as a three-dimensional object pretty quickly. You can see what it looks like. But you've got to be able to draw it exact same scale as this one. So let's look at this one. First of all, what would we call this? What kind of object is it? Not a cube, because this is not a square. Okay, almost, that's one of the words. Nice. Rectangular prism is the name that we would give it. Or, yeah, rectangular prism, we'll leave it at that.
Is this 5-4?
Yes, it is. Okay, so basically now what we've got to do is we've got to draw it all together. And we've got to be careful that we have the same scale. So I know this is a little tough because you'll be flipping back and forth, okay? But let's figure out, if we were to draw a three-dimensional view of this, we'd probably draw this face first. How many grid lines long is this?
6.
How high? So we've got to make sure that on this page, when we draw the three-dimensional view, we draw a 6x4. Now, let's draw the top. The top on the previous page, notice again, it's 6 long, which makes sense because it has to match up with this when we put it together. How deep is it? Now, this is where we got to be a little bit, like we could use a ruler and measure it, but think of diagonal units. This is almost 2 diagonal units, isn't it? Like, let's say from this corner to this corner is 1 diagonal unit. And this one to this one is 2, but it's not quite 2. So it's 1 and close to 2. Yep. Well, it's still the same here. Which ones? All of these will be one and almost 2 diagonal units.
Like the first face right here, and the one that's directly behind it. That stays in between. So we're not going to say that it's.
That's again almost 2.
But you just want to do that, right?
No, stick to almost 2 diagonal units. Thank you. Okay. So here's how we would draw it. Almost 2. So go through the corner to corner and then go up about there. Don't finish at the next corner. And then do a similar one here. Yep. And wouldn't there be a similar one here? Almost 2 diagonal units. And now we can finish connecting. We don't have to draw the edges we can't see behind. That's good enough. Okay, are we perfect? No, not perfect, but we're really close. So that would be an acceptable way to go from an exploded view to a three-dimensional view. And just a question on scale with that. So the dimensions of the scale drawing, if we were to measure them, the length is 1.5 inches, the width is 1 inch, and the depth is 0.625 inches. If the exploded view is drawn to a scale of 1 inch equals 1 foot in reality, what are the actual dimensions of the object? Don't overthink this question. This is not terribly difficult. If the scale length is 1.5 inches, what's the actual length in feet? If it's 1:1, it's the same. So the length is going to be 1.5 feet because the scale is 1:1. The width is going to be the same as the width on the scale, except in feet, or 1 foot. And the depth, well, if it's 0.625 inches in the scale, it's 0.625 feet in the actual. So that was pretty straightforward. 1:1, you just write the same numbers, you just change the units whenever it's 1:1. So that's a pretty basic figure. Let's get a little bit more complex. Now you got to be able to interpret this properly. Is there anything in front? No, because we can see a back rectangle, but we can't see a front rectangle that closes it. So this is going to be open. Okay? I mean, what would we call this? Yeah, really, that's the best we can do it. Shelving unit or shelf. Okay, so now we got to figure out how do we draw the 3D representation of it. Well, I always like to start at the front, but there's no front in this one. So I'm actually going to start at the top one. So I'm going to basically redraw this top one on the next page. And so this top one has a length of 8 grid lines. And basically we can say it's got a diagonal of two diagonal lengths. So 8 by 2 diagonal we can start with. Eight by 2 diagonal. Wait a minute. Did I do 9? No, I did 8. I saw you counting there. Just wanted to make sure. Let's draw another shelf. Or actually, what should we draw next? What would be like, which component parts would be partially hidden when I put it together in 3D, and which ones would not? Well, the top would not. What else would not have any part of it hidden when I put it together? The right side? If I put the right side together, like if I push the right side there, I'm going to be able to see this whole thing, right? So let's do that one next. So that it's also a diagonal length of 2. And how long is it? 410? Nope, 11. So it's 11 down. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. Diagonal length of 2. And then that would connect up like so. For the left side, we can see this part of it that goes down 11. But I'm not going to be able to see parts of the inside because the shelves are going to be in front. So why don't we draw the shelves next? The question is, where do I start? So here's the top. Where do I start my top shelf? How many down? 3. Because if you look at the exploded view, look at the difference between this top corner and this shelf corner is 1, 2, 3. And then it's 1, 2, 3 again, 1, 2, 3 again, and then 1, 2 to the bottom. So I'm going to go down 1, 2, 3, and then I'm going to draw a diagonal here. That's the shelf. I can't see some of the shelf. I can't see the shelf on the right-hand side because this right panel is covering it. So that would be the shelf. The next shelf is 3 down, so I do the exact same thing. The third shelf is 3 down, so I do the exact same thing. Now this is where your perspective skills come in. It looks like we're missing some things. Down here? Is there anything down there? It's the back. So there is nothing down here, but I did forget, I can see part of the left side here, 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 and here. So that finishes it off. And you can see we've got our shelf. So what I would suggest you do when you're given an exploded view and you go to a 3D representation of it, start with the sides that you can completely see when you put it together. So I started with these sides. Then work in the sides that you can see most of it, but not all of it. And then fill in the remaining gaps. Okay? That's one, it's not, I mean, you guys are quite good with this stuff, so that's just one way. That's the way that I found a little bit easier. To answer one final question, again with the dimensions. So here, when we talk about the dimensions, we're going to talk about 3 parts of the shelf. The shelves themselves, the backboard, and the side panels. So on the scale drawing, the shelves are 2 inches by 1.5 inches. The backboard is 2 inches by 2.5 inches. And the side panels are 1.5 inches by 2.5 inches. If we change that to actual dimensions, we see that 1 inch represents 1.5 feet. So doesn't that mean that we have to multiply all these dimensions by 1.5? So for the shelves, well, the original is 2 inches by 1.5 inches. To find the actual, I take each one of them and multiply by 1.5. So I get 3 inches by 2.25 inches when you do your calculations. So those are the actual dimensions of the shelves. The back panel measures 2 inches by 2.5 inches. To find the actual in feet, I multiply each of those dimensions by 1.5, and I get 3 inches by, what's 2.5 times 1.5? Sorry, I've put the wrong dimensions here, you guys. Should be feet. Because we're changing to feet. 3 feet by 3.75 feet. Okay. And then the side panels. Well, what are the sides on the scale? They are 1.5 by 2.75 inches. To find the actual in feet, I got to multiply each of those by 1.5. And I'll get 2.25 feet by 2.75 times 1.5 is 4.25 feet. Okay. So that's changing scales. So that's how we go from an exploded view, put the exploded two together into a three-dimensional representation. How do we go the other way? Well, so here we have a three-dimensional cube. This is a cube because the front is a square. It measures 4 grid lines by 4 grid lines. I've gotten to do an exploded view of it. Okay? Yeah. Times 1.5. They're all times 1.5. Do you need to see that again, Beatrice? Okay. So what we're going to do is we're going to explode this one, the one at the back, the one up top, the one on the bottom, the one on the right, and the one on the left. So I got to draw 6 shapes, all squares, either a straight square if you're looking at it straight, or it looks like a parallelogram because you're looking at it from an angle. So how do we do that? Start with the front one. So we just need to draw a 4 by 4. There's the front. Let's do the top, because we can also see all of that. It doesn't matter how much you go up. Like if you went up one, if you started drawing it here, that's fine. If you went up further and started drawing it, that's fine too. It's just the dimensions have to be the same. So I'm going to go 2 up. It has to be 4 long. What does the diagonal length have to be? Well, look at the diagonal length of the original. Doesn't it look like it's about 1.5 diagonal lengths? So about 1.5. 1.5 connect. Just to spread it out a little bit more. If I went 1 up, it's just as correct. Not necessarily. The distance that they are apart when an exploded view shouldn't matter, shouldn't affect the dimensions when you put it together. Like this is still going to be 4 by a diagonal length of 1.5, regardless of whether it's here or here. It doesn't matter. It won't matter. Like here, okay, let's draw the right side one. I could draw it here. I could start it here. I could start it 1 away. I could start it 3 away. It doesn't matter. As long as the dimensions are the same. And remember, it has a height of 4 and a diagonal of 1.5. So it's going to look like that. So this one I put 2 apart. If you put them all 1 apart, you're just as correct, because it's still going to be the same thing when you put it back together.
I just mean like, not the actual amount of distance, but relative to each other. Like each actual side, like if one side is, or is that the same argument? Like if one side was like 1 apart and the other side more than 1 apart?
When you put it together, it's not going to make a difference, because when you put it together, it's still going to be the same thing. It's still going to be the exact same shape when you put it together, no matter how far apart they are in exploded view. Because like how far apart is not relevant to the actual dimensions, right? Like this has to be 4 to match up with this. This has to be 1.5 diagonal units to match up with this when I put them together. How far away this is doesn't change that fact. That's sort of the way that, okay. Let's try a couple more and see if it gets better. Okay. So let's do the right side one. And again, like here, I'm going to start here. Has to be a height of 4. Has to be a diagonal length of 1.5. So there. So here, notice how far away this one is. This one's 2.5 grid lines away. This one's 2. Doesn't matter. All it has to do is match up with these 2 faces when I put it back together. For the bottom, start wherever you want. Could start down here, go 1.5, 1.5, like that. That's a little bit far away, but still correct. There's only one that I'm missing, and that's the back. How do I draw that? I think no matter what I do, part of that back is going to be hidden. So let's say we draw it here. We start it up, the top will start here. Well, I can see this, I can see this, I can see part of this horizontal, and I can see part of this vertical. So we could do it like that. You're not going to be able to see the entire back in exploded view. And that's going to be the case with pretty much all of these. Okay, let's try the bookshelf again. It looks very similar, but it's slightly different dimensions. And it's got a bottom. So it's a little bit different. Okay. So here's our bookshelf. Well, why don't we start with the top one? Top's usually safe. We could start with the top and the right because we can see all of those. So if we do that, what do we got? How long is this? 7. And what's the diagonal length? It's less than 1 diagonal length. So 7 long, 3, 6, 7, less than 1 diagonal length. There's the top.
But on the other side, you pick one diagonal. Oh, wait, I thought you said less.
Yeah. This isn't 1 here.
Oh, sorry.
Yeah, that's okay. Yeah, if you look at any one of those ones on the diagonal, it will be less than 1 diagonal length. We could draw the right side next. And we could draw the left side at the same time in exploded view. Oh, first of all, we need the length. How long is it going to be? Well, where can I measure? I can measure from here to here. So it's 2, 4, 6, 8. 8 long, less than 1 diagonal length. So 8 long, less than 1 diagonal length. So I'll draw it like this. 2, 4, 6, 8. So it'll look something like that. And I could draw the other one over here. 2, 4, 6, 8, less than 1 diagonal length, and then those will connect vertically. So I've got those done. Let's do the shelves because they're all going to be the exact same as this. The question is, how far do I go down? Yeah, 2. So to get the next shelf, I have to go 2 down. Well, when you're lining the shelves up, though, that's different because the heights have to be the same, don't they? I mean, yeah, you're kind of right. I understand what you're saying. Yeah. But if you keep the shelves the same distance apart vertically, it helps. Yeah, well, are they all 2? Yeah, they're all 2. So just go, yeah. That's fine like that. If you went a little bit further, I mean, as long as, I'm more concerned about, are these the, whoops. Are these the correct dimensions? Yeah, like if you put these, if you spread these out more, I'd still give it to you. And we do have one on the bottom, don't we? This time there is a bottom to it. So the only thing left is the backboard, which no matter what, I'm not going to be able to see the entire thing. I just got to make sure that that back rectangle has dimensions of, if you look at the original, 7 by 8. So you could start it here if you wanted to and go 2, 4, 6, 7, and then you have to go down 8, but all these shelves are going to be in front of it. So 1, 2, 3, 4, 5, 6, 7, it's going to go down to here. And then it's going to come across here. And then I can draw this whole thing here. So that, yeah, it looks a little weird, but just as long as you have the dimensions right. It has to be 7 by 8. 7 long by 8 wide. If you move this back panel, like say you drew it over here, that's fine. If you drew it over here, that's fine.
I think what confused me is the shelves, because in a cube, I can imagine them all being pulled like in a straight line to the center, but with the shelves, it's like, with the backboard, like at one point, you know that the shelves are like that, you know?
Yeah, no, I understand what you're saying. So yeah, that one's a little bit trickier to draw. It's a little bit trickier to visualize. At least I find it so. Okay. Otherwise, that takes care of this unit on design modeling. So I'm just going to give you Friday as a work period. And we'll reconvene on Tuesday, and I'll probably just give you I'll give you a hand-in assignment either on Tuesday or Wednesday.
Is there a lesson on Tuesday?
No, there'll be a lesson on Wednesday. I'm going to start.
So it's like a 5-minute thing on Tuesday, and we come at the end, because.
Fine. Just make sure and come and grab it.